Feeling of the shear force. What we can know from the shear force diagram. To get the feeling of the shear force diagram, let's take a very easy example. There is a simple form of a bridge. A rectangular beam is supported at the two extreme ends by two roller support, and no other support is there in between the two extreme ends. Let's assume that there is no car on the bridge. Now you walks onto the bridge, and stands right in the middle of the bridge. Now if you want to know about what happens in the beam, then you must study the forces in the beam. Stop for a second and think about the forces. Everything is in equilibrium, man is pressing the beam. The beam may have bended a little bit, but to make the analysis simpler, assume that there is no bending. Let's find out the direction of the forces, as the weight of the man is acting vertically downward, and being the roller support, they will not offer any force in the horizontal direction. Let's go into the middle of the beam, as there is only one external force, and that is also in the vertical direction, so if we go by the Newton's third law, that is action-reaction law, there will be a reaction force applied by the beam in the vertical direction, means on the plane of cross-section, and my friends, the force that acts on the plane of cross-section is known as the shear force. Now we will start the mathematical analysis of forces. Assume that length of the beam is 2 meters, and weight of the man is 10 kN. I know no one wants to be that heavy, but don't worry, I just wanted the calculation easier for the later parts. Move on, now before going in the deep. Let's make the beam look simpler. From now I will not draw the roller and the man. The rollers are represented by the little triangles, and the man with the vertical arrow. Weight of the man is 10 kN. As we are studying the forces on the beam, we do not consider the weight of the beam. Mark the point ABC. Let's get rid of this diagram. This moves to the corner. Now to find the forces on the beam, draw the free body diagram of the beam only. There are two reaction forces, one at support A, another at support C, and of course 10 kN force is acting vertically at location B. Let's write down the equilibrium equation. Summation of all forces are 0. So Ra plus Rc equal to 10 kN, and by the symmetry we know that Ra is equal to Rc. On solving above two equation, we will get that Ra is equal to Rc is equal to 5 kN. Let's get rid of this diagram, and the calculation as well. This moves to the corner. Write the values of Ra and Rc, and both are same 5 kN. Now the game starts. To check the shear force value, in the AB section cut a section at a distance x from the point A. Net force on this part is 0, that gives Ra to be 5 kN. And this value is independent of the distance x, so in the section AB value of shear force is positive 5 kN. Now we will find the shear force in the BC section. First get rid of this calculation and this free body diagram. Cut the beam in BC section, this is the cut out part, this is shear force. Using the same concept what we used for AB section, we will get the shear force. Net force on this part is 0, so shear force plus 10 equals to Ra, that gives shear force equal to minus 5 kN. Again this shear force is also independent from the distance x, so shear force in BC section is constant. Now we will draw the shear force in the beam, along the beam length, and the diagram, which we will get, is known as shear force diagram. In the AB section shear force is constant and plus 5 kN, while in the BC section shear force is constant but minus 5 kN. Here the shear force diagram of the bridge completes. The point that you must observe is, external force is 10 kN, but no section in the beam has shear force 10 kN. The difference of the shear forces is 10 kN at location B. Actually 10 kN force is distributed in this and this section, and both are carrying 5 kN shear force. Thank you. If you have any question then shoot out in the comment box.